Okay, and to round out our derivative rules we've been looking at, we're going to look at the derivatives of exponential and logarithmic functions. So first of all, this number e, Euler's number, as far as its numerical value, 2.718, goes on and on because it's an irrational number. And as far as figuring out where that number actually comes from, there's a few ways to define e. One of them is the sum from n equals 0 to infinity of 1 over n factorial. So that'd be 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2 factorial, and you go out infinitely far and that number converges to e. Or we could take the limit as n goes to infinity of 1 plus 1 over n to the power of n. Turns out that would converge to e. And e just turns out to turn up in all sorts of places. You've seen this formula right here for continuous growth. If you're in statistics, you might have seen this formula for the normal distribution curve. And there are many, many other places where e makes an appearance. In calculus, we'll find some really interesting properties of e. So if we look at the graph of y equals e to the power of x, at that point 0, it appears that the slope is about 1. It turns out that it is exactly 1. So we're going to make that assumption. And using our definition of derivative, limit as h goes to 0, that's e to the power of 0 plus h minus e to the power of 0 over h. If we've made this assumption that that slope is 1, then that limit equals 1. So we're going to bring that back in here in a few more steps. Okay, so now we're going to go ahead and see if we can find a formula for the derivative of y equals e to the power of x. And we're going to do this by using the definition of derivative. So here's our definition of derivative applied to e to the power of x. And instead of writing it as e to the x plus h, we can make that e to the x times e to the h. And since we have an e to the x in both terms there on top, we can factor that out. And since e to the power of x doesn't depend on h at all, that can come to the outside of the limit. And we should then notice that this limit right here is our definition of derivative of e to the power of 0, or e to the power of x when x equals 0. And we said on the previous page that that's 1. So the derivative of e to the power of x is e to the power of x. Whoa! Neat! Rad! Awesome! So it's a really cool result. E to the power of x is its own derivative. If you take the derivative of e to the x, you get e to the x, meaning every single point on that curve is also the value of its slope at that point. Okay, so now let's go ahead and take a look at the derivative of a to the power of x. So a could be any base, not just e. Well, we can write that as e to the natural log of a to the power of x, because e to the x and natural log of x are inverses. And we know that the derivative of e raised to a power returns itself, so that's e to the power of x natural log of a, times the derivative of the inner function, we're using chain rule, and the derivative of x is ln of a because ln of a is a constant. And we can go back from e to the x ln a to just write that as a to the power of x. So the derivative of a to the power of x is a to the power of x natural log of a. And notice if this was e to the power of x, you'd get e to the power of x natural log of e, but natural log of e is just 1. Okay, so here's what we have so far. The derivative of e to the x is e to the x. The derivative of a to the x is a to the x natural log of a. And now we're going to take a look at the derivative of natural log of x. So we're going to rewrite this as e to the y equals x. And we can use implicit differentiation. The derivative of e to the y is e to the y times the derivative of y with respect to x. Derivative of x is 1. So we have 1 over e to the y, but we've already said that e to the y is equal to x. So that's 1 over x. So the derivative of natural log of x is 1 over x. And now we can find the derivative of log of any base. Since natural log of x is log base e, we could find the log base 10, log base 2, log base anything. So if we try to find this derivative, let's use our change of base rule. That's equal to the derivative of natural log of x over natural log of a. And notice we don't have to use quotient rule here. Natural log of a is just a constant value, so this is really 1 over natural log of a times the natural log of x. So that's 1 over natural log of a times 1 over x. So for any base other than e, the derivative of log base a of x is 1 over x natural log of a. And here are the 4 derivative rules we get out of today's lesson.